Okay. Sige. Ang pinag-uusapan namin ngayong GRASS ay activity or Fourier transform. It's a very important tool. Kailangan lang na marunong ka nang gumawa ng artificial or synthetic images, GRASS. Sundan mo yung activity natin last time.
Opo, nasundan ko naman po yan.
So ngayon, ang pinagagawa ko kay Bea, sundan niya lang itong codes na to and see what happens. Like, ito, you create a circle and save it, pero ito sa baba, you create a circle and use it. Alright. What if, Bea, you share your screen and then I'll just dictate para yung mismong results mo, yun yung output mo, okay?
Oh, okay.
I'll stop sharing and I'll lead you through it, okay? Sige, I want to see your screen para natin kung nangyari. Okay. Right. So, you can actually, yeah, sige, run mo na yan. Did it run?
I got an error.
Must be an M/3 array. Use im to gray for RGB and grayscale image. Okay.
Yeah.
Im.
Oops.
Yeah.
Yeah.
Okay. Okay. It's odd looking, no? But it's fine. It's all right. Relax, relax. It's okay. Don't panic. Oh, by the way, you can also remove uint8 kasi image SC naman to. You use only image 8, uint8 if you're using imshow, ganyan. Okay. All right. Sige, just run it. So now look, parang mostly black, all right? But actually the corners, if you observe the corners, they're there.
Yeah.
And this is where you need to use the FFT shift, right? So if you could kindly, do you see the step there where you put an FFT shift?
Image.
You can display mo na yung yeah. Yeah, okay lang yan. Shift. Yan. So what this does is, that's correct. Look, it's very intelligent. No, not I. FIK.
Oh, FI.
Look, it's intelligent. It suggests, no? Sobrang pinadadali ang buhay natin. Okay, sige. All right. Oops. Yeah, okay, cool. Yeah, look at that. There you go. Now the quadrants have been shifted. And now what is in the middle is typically what is zero, no? Yung zero frequency FX. Now, could you add a line, color map, after this, color map hot. Hot, yeah. Oh, you can choose, yes. Okay. Okay. Para lang mukhang laser. Okay. That's it. Now you have it, and if you zoom in, you can zoom in here. Can you do that? If you, yeah, you take the plus. Okay, you saw a plus sign coming out.
Yeah.
You click the image. You can, or you can exit it. Yeah. There. And then you can select the circle there so that you can see it. Yeah. Oh, Eva, what does that remind you of? Airy pattern, right? If you remember your optics, the Fourier transform of a circle is an airy pattern, a circle with rings around it. This is analytically known as a Bessel function. Okay, the first kind. Okay, and this is well known in thing about optics. Every time you have a pinhole or a circle, it diffracts, and you shine light. If you shine light behind a pinhole, a circular pinhole, and you observe, like a laser, no? Does this remind you of a laser experiment, guys? You have a pinhole, you shine a laser behind it, you look at the pattern very far away from the pinhole and the laser. What happens is the waves diffract and form a pattern very far away from the pattern or the aperture, okay, born from the pinhole. It's called the Fraunhofer diffraction. Okay. And the nice thing is, give me an aperture, take the Fourier transform, what comes out is the Fraunhofer diffraction of that aperture. Okay. So essentially you simulated the Fraunhofer diffraction of a pinhole. And therefore,
It's 9 o'clock.
whatever arbitrary pattern you put there, you take the Fourier transform and display it this way, that would be the diffraction pattern, Fraunhofer diffraction pattern from far away. So what's crazy is, guys, ito yan, ganito yan. If you can somehow invert Fourier transform this, because you see the Fourier transform, guys, of anything kind of looks like the thing itself, although my distortion. Like this is supposed to be just a circle, right? Pero from far away, it looks like a circle with rings. And so these rings, you can think of that as a bit of a distortion, okay? It's not exactly the same as the object that produced it. And so, but if you already have this pattern, and if you inverse Fourier transform this, technically you will be able to recover the original pattern. So go ahead and try and, what is this? Fi gray, ano? There is an inverse Fourier transform a function, okay? So I'm deviating from the procedure, but go ahead and after color map hot, I'd like you to create FFI gray. Parang Fourier transform ulit. So equals I FFT, which means inverse Fourier transform 2. Do you see that? It comes out as a suggestion. Do you see that? There. And then the argument would be Fi gray. Okay. All right. Sige. Go ahead and run that. And then we haven't displayed it yet, no? We're displaying it. So go ahead and display this as an image SC, abs FF gray. See what happens. Ooh, fingers crossed. Hello, welcome back.
Interesting.
Diba?
Yeah.
What this lesson shows, guys, is kasi, tell you what, guys, have you experienced playing with lenses in your, I don't know what physics you did that, but Grass, did you take physics 72? And did you have some optics experiments there? How about you guys, yung 103 nyo, nag-play ba kayo with lenses?
Yes. Hindi po ako, parang hindi po. Maalala.
But you know lenses can create images, right? Like you pick a lens, convex lens, and parang telescope ba? Diba?
Ako.
Telescope. From far away, you can create an image of something, right? Parang magnifying lens ba? Or kaya nakakasunog ang magnifying lens kasi it creates an image of the sun, right? Focuses it on a spot. You can do the same for lenses as well. You just take a convex lens, point it at the window and observe the pattern on a piece of paper behind it. Move the paper until you see an image of the scene outside the window. The point is actually any lens does a Fourier transform. Okay. Again, I'll repeat. The nice thing about the Fourier transform is it's a nice model of a lens. And since we're talking about imaging systems here, this more or less allows us to model what happens when we image a system, of course, using lenses, using cameras. All right. So, Bea, if you use arbitrary patterns now, the ones we made earlier, like the square, the slit, have you had a double slit? Kasi di ba may, naalala nyo yung double slit experiment natin?
Yeah.
You remember what kind of pattern comes out of a double slit, Young's double slit experiment? Okay. So if you can load that image, go ahead and see what happens. If you, all you need to change here is the file, right? Bea, di ba? Everything is okay except in, I mean, I equals imread, you just change the file name and that's it.
Oh, oh yeah. Just go ahead.
What do you have in your file? Yeah. See, okay, that's a square. Let's see what happens, how a square looks like. You can zoom in on that one. Oops, too big. Sige, some more. Can see some more. Yan. Okay. Now that pattern is known as a sinc squared function. Or no, sorry, sinc function. Looks like a square, but it has some ringings on the sides, right? It's like yung kanina, circle mo ang medyo circle, pero may ringings on the sides, right? So, next is yung properties ng Fourier transform. Magkabaliktaran yan, guys. Ang Fourier transform kasi, look, a Fourier transform essentially is something that transforms a function in one space into a function of a space which is 1 over the dimension of that space. For example, grass, naalala ko to kasi pinag-lecture ako sa inyo sa EDC tungkol sa Fourier transform nung nandun pa si Mickey Fudalig.
Si Mickey. Opo.
There was an interesting application, guys, ng Fourier transform. They needed to listen to something. Ano nga ba yun? Yung napakahabang signal na yun na kailangan i-Fourier transform para malaman kung saan most likely merong reserves.
Baka namin, geophysics, team.
Yeah.
Hindi po kaya magnetotelluric signals?
That's it, magnetotelluric signal. Okay, exactly that. The point, guys, is, basta imagine niyo, the Fourier transform itself, whether in time or in space or in whatever dimension, like here, this is space. These images are in 2D space. When you Fourier transform it, it transforms into an image in 1 over dimension space. So, ibig sabihin, just like in time, analogy na in time, you have a time signal, a wave, sinusoid wave in time. Fourier transform that, you transform it into a signal in 1 over time or 1 over second or in hertz or in frequency space. So if this is space image in 2D space, when you Fourier transform it, you transform it in spatial frequency space, 1 over x and 1 over y. Okay, x and y being dimensions. All right. Because of that, di ba inverse guys? In space it's x, but in frequency it's 1 over x. Ang isang sa mga property ng Fourier transform, guys, is yung magkabaliktad yung itsura ng kanyang Fourier transform. Ibig sabihin, Bea, kung malaki yung circle mo, yung image ng circle mo, pag Fourier transform mo yan, maliit yung itsura ng Fourier transform niya. Pero pag maliit yung circle mo, pag Fourier transform mo yan, malaki yung itsura ng airy pattern mo. Do try it. It's very important to remember this, to get insight here. So what do we do, Bea? You just copy the circle, and let's just circle function. We'll generate the circles and generate different radius and see what happens. We make a large radius, large na to medyo eh. Now, you create a circle with a very small radius. Tignan mo mangyayari. Like right now, kulang siya ng ano, wait. Generate ka na, yan. Okay. Yan. Okay. Would you like to put a section break so that, you know, you can just, and you don't need to save the images. We can already, yeah. You can put a section. You're very good. Okay. Now, right now it's at, no need to read. No need to read. In the next section, in the next section, you, instead of reading, we will use A, no? So we comment this out, and instead we say I gray equals
then we make this smaller also.
yeah. Okay, too small. So all right, fine. Sige. Let's have a look first at this first. There you go. It's kind of tiny, so if you want to zoom in, maybe you could. All right. All right. You run the whole section. You run the whole thing, no? Not the section. So it's a tiny. That it's good, no? You can see the mesh. But now we have to correct this a bit. We can use just I gray equals double A, no? Kasi logical siya, 0 to 1. Just convert that to double. Yo. It's double. Anyway, it's all right. Okay, sige, now you can run it. Oh, okay, all right. Crazy patterns, but have a look. Are we doing a square? No, no, wait, hang on. Should be good. Sige, run mo na tong section na to. It should be good.
Oh.
Is it running? Wait, hang on. I gray equals double A. Teka, hindi siya circle ah. Wait. Ate, wait. Double. I gray. Okay, could you go to section, please? Click section sa taas. Run section. Yan. Okay. Wait a minute. It's not reading our A.
Oh.
Oo nga eh. Hindi niya. Okay. Wait lang ha. Wait lang. Ano pa yan eh? Parang, tignan mo, i-akit mo nga ate. Tapos na ba siya? Mukhang square pa rin yan. That's wrong. This is still the... wait. All right. Maybe it's too small. Could you change the mukha ng pixelized yung like a square, no? Baka masyadong pixelized na. Could you change it to 0.1 instead? Yeah. Okay. Yawn. I think masyadong maliit na yung radius mo, Bea, na tingin niya na is circle yon, no? I think tingin niya na 4 na pixels yon, kaya ganyan. Look, it looks like a large di ba? We don't need to zoom in, di ba, Bea? Kaya nag-zoom in pa tayo, right?
Yeah.
Okay. So pag pinalitan mo naman, kung kunyari yan, gawin mong 1 greater than 1, liliit naman yung Fourier transform niya. Yan. Okay. So this time, malaki yung circle. Okay. Tapos, yung maliit na yun, yung malinggit na yun, iyon yung Fourier transform niya. Maliit naman. Diba? Yun. Yep. Okay. Looks like it, more like, this is pixelated, kaya ganito na, no? But we were able to recover the large circle again. Okay. Okay. So now you know how to make the Fourier transform of a circle. Now you can just arbitrarily read an image, any image, kahit itong mga pictures natin. Gawin mo lang grayscale, tapos i-Fourier transform. Anything can be Fourier transform. And the thing is, pag in-inverse Fourier transform mo, marirecover mo pa rin yung yung original image. This is a reversible transform kasi makukuha mo pa ulit, mababalik mo pa ulit yung image. Unlike histogram, guys, pag kinuha nyo yung histogram ng image, no way can you recover the image just by being given a histogram, di ba?
Yeah.
But the Fourier transform is a different kind of, it's actually like a histogram, but it allows us to recover the image because it has a basis, no? A sinusoidal basis. Once you have sinusoids, essentially ang Fourier transform kasi ganito guys it tells you ano bang mga sinusoids ang naandyan sa image at gaano kataas at anong frequency. And given those two information, what's the amplitude of the sinusoids, different sinusoids found in the image, and what are their frequencies in X and in Y? That allows you to, that's the reason why we can recover the image, because we have what are known as basis functions. Okay? Basis functions are the sinusoids. Sa histogram, walang basis
It's
functions.
9:15.
Okay? That's why we can't recover. The ordinary histogram, gray level histogram, has no basis function. That's why we can't recover the image. But for a Fourier transform, we can because it has basis functions. Okay. Sige, next part. Sige, Bea, could you show yung activity? Tapos let's go through the other parts.
Okay.
Adi, are you getting this? Yuhu, Adi.
No questions naman po so far.
Okay. Na-try mo na ba to?
Di pa po.
Okay, di bale. But here's something nice, ano? Gawa kayo ng artificial double slit. Kayo ba'y nakagawa na ng double slit experiment, yung Young's double slit experiment, guys, sa tanang buhay nyo ng physics?
Again, 103 maybe.
You had an aperture with a double slit, ganon, tapos you shine a laser behind it. Parang ganon ba?
Yeah.
And then you looked at the screen and then you saw a sine wave, parang ganon, right?
Mm. Yeah.
Okay. Well, you can create a double slit, kunyari in Paint. Those are just two white lines, di ba? And then you Fourier transform it and see what happens. You're supposed to see something like what you see in your experiment. Anyway, moving on, ano pa yung next na kailangan gawin?
The letters thing. Is my no? Is the activity scene also? Yeah.
Sorry?
Is the PDF file also seen?
Yeah, nice. It's in split screen, right?
Okay.
Ayan, simulation of an imaging device. Okay. Yan na. So here, kayo ba ay nakagamit na ng microscope? Alam ko si Grass nakagamit, madalas gumagamit ng microscope yan. Pero Bea, Adi, kayo ba pre-pandemic, were you able to use a microscope, say in your bio or in high school?
Yes.
Okay, you did? All right. This next part of the activity, simulation of an imaging device, simulates what you will see in a microscope or a telescope. Promise. Kasi may lenses lang yan eh. And the Fourier transform, again, simulates lenses. That's why the title of the activity is simulation of an imaging device. If you look under a microscope and you look at a cell, the cell is so tiny, or a dust particle under a slide, no? Inside the slide under a microscope. It doesn't look, well, I don't know if you've done 100 times, but usually it's seen under a 100 times objective, yung pinakamataas, pinaka-powerful na objective. What you will see is similar to what we just simulated, Bea, yung circle na may rings around it. Ganun ang itsura ng mga cells na sobrang kalinggit or particles na sobrang maliliit. You don't see it as a perfect, circle with sharp edges. Instead, you sort of see some ring around it. You notice that?
Yeah.
The same thing also happens when you observe stars using a telescope. when you point the telescope up in the sky, no, night sky, look at the star. Star is like a dot, right?
Mhm.
But when it goes through the lens of the telescope, what you see is not a dot. What you see, it depende ha sa telescope, no? Especially in pinakamalaya, no? What you see is there seem to be a faint ring around it. Okay? And it's again because of diffraction and the actions of the lenses and all, right? Now, you generate here in this activity, simulation of an imaging device. What happens is, you will simulate what happens if you're using a lens of different apertures. How would an image look like? How would an object look like if you're using a lens of different aperture sizes? If this were a microscope, it's like you're using a lens having different magnifications. Okay? Okay?
Mhm.
All right. So, but the magnification is affected by the aperture. The aperture is the hole around the lens. Numerical aperture din ang tawag sa kanya. Essentially, the larger the aperture, the more rays it can get in. It can accept. The larger the aperture, the more rays it can accept. The more rays it can accept, the sharper the image can look. The smaller the aperture, the smaller the number of bundle of rays it can collect. Therefore, it will not completely reconstruct the image. So go ahead, Bea, and try this step. Meron ka na bang NIP? The NIP can be made by bitmap. Paint. You can do that using paint, no?
Okay. I don't remember.
But make sure that it is the same size as our, for example, what do you want to use? 200 by 200 or 400 by 400? Kunyari,
It's this
maybe
one.
400, paano ba mag-resize dito? Let's make it 400 by 400, ano? And
Okay.
yung! Awesome! Sige. We should match, mamaya, pag nagpo-program na tayo dun sa MATLAB, just make it match to the size of the image, no? So, do you want 200 by 200? Sige, bahala ka. It's okay. You can probably...
Oh.
Wait, bakit alisin mo yun, maintain aspect ratio, te. And click mo yan kasi yan ang mag-keep ng ano. Yan. Yeah, lit pala. Okay. Sige, pipe. Ano ng text dyan? Lit naman?
Bigger.
I think it's okay. That will do for now, I suppose. Sige, save that. Bitmap sana to.
Oh, okay. Wait.
Probably PNG will do, but sige lang. Maybe PNG will also do.
Okay. And then I...
Okay. All right.
Okay.
Now let's follow through with this will require following the instructions dun sa Okay, here's the thing. The lesson says this is convolution. Convolution keyword is convolute. Convolute means distort. Convolution actually mathematically is a process of two functions. One of the functions is flipped and shifted and multiplied to the other function and integrated. What a complicated process. If you look at the page before this, it explains the integral, no? If you go to the lecture, if you just slide up to the first part. Bea. Akit mo yan. Yo. Convolution. Teka, lagpas na tayo ng convolution. Yan. Now, have a look at equation 2. That's the convolution process. But essentially, it's a smearing. This function, if you look at how it works, you have two functions. One function is slided over the other, and you integrate as per slide position. Okay? So essentially, convolution is a smearing. Smear. You're smearing one function relative to the other. And essentially, this is a model of how any instrument at all, any linear instrument works. When you have a measuring device and you measure something, what you actually measure is not exactly what the object really was, no? But there's a bit of distortion due to the instrument's transfer function. Transfer function, remember 183? Okay? So ganun yun. Ano yan talaga? Given yun. And so it is with imaging devices. There is a smearing because of the lens of the imaging device, no? So here we model the smearing through a Fourier transformation. Because of equation 2, and because of the properties of the Fourier transform, if you Fourier transform a convolution, it's a multiplication in the Fourier space. It's equation 4. Okay? So essentially, mamamodel natin anong itsura ng image. Ang image, bali, tingnan niyo equation 4, no? Yung G, teka na ba? Sabihin natin yung G, sabihin natin yung F is yung ating original object. Ito si NIP image na malinis, na kagagawa lang ni Bea. Yung G, iyon yung transfer function ng camera or ng telescope. Okay? And yung H, iyon yung image na makukuha natin. Okay? So it's not exactly F. It's a distorted version of F. Equation 4 is in the Fourier space. Equation 3 is in the image space. So let's do equation 3. So essentially, ang purpose nitong activity na to, dito, kukunin natin tong equation 3. Titignan natin anong itsura ng NIP pag tinignan mo under a telescope or a microscope by using equation 4, which is essentially Fourier transform. All right. First thing is load the image ng NIP. Sige, te. By the way, Bea, alam mo ba kung paano yung, hindi mo na kailangan i-run lahat, kahit line per line lang, pwede mong i-run?
Line per line is lang. I know pa per section.
Pwede din. Sige. Could you kindly read the NIP image dyan sa section na yan? Okay, don't forget to assign a variable to it, like say I3 or I don't know, give it a variable. Bahala.
Also.
Okay, semicolon. Okay. Then you can actually read it as well. ImShow, kasi it's an image. So you only use ImShow if you have an image. Show F, right. And then you can run that section only, yes? Yeah, that section. Let's see if we see the NIP coming out. Yon, perfect. All right. So in our memory also is the aperture, right? Nandiyan yung aperture na circle, right? Yung arbitrary radius na pwede natin gawin, right? So you can run the section. Okay, let's go through the steps. Pwede ba, te? So create a 128, anyway, 200 by 200 yan. Create another 128 but 200 of a circle centered against a black background, and this image represents the aperture. Open both images as grayscale images. Get the 2D FFT of the NIP image and FFT shift the aperture image. Okay, so now you have a circle somewhere there, right? That's A. Tama ba, Bea?
Yeah.
Your circle is A, right?
Yeah.
And you're asked, so ganito kasi yon, the circle is already, if you're simulating an imaging system, the circle is the aperture of the lens. And actually, it's already in the Fourier space. So this is the reason why when modeling an imaging system, you don't need to take the Fourier transform of the circle. This is already in the Fourier transform, the circle function. What you need to do is take the Fourier transform of NIP. Could you do that, please? In that section there downstairs, you take the Fourier transform. Hehe. Girl, the FFT shift, FFT2.
Oh.
Okay.
Double. Do I make it double? Or...
That's all right. Double, yes, correct. Kasi it's yeah, semicolon. We don't need to see it. We don't need to run it yet. That's fine. Relax. What's next that's needed to be done? Sabi dyan, okay, so when we run this, when we run the circle upstairs, we have the aperture. When we run this section, we have the Fourier transform. What we need to do with the circle,
It's 9:30.
is we have to FFT shift it. We have to quarter it and put it back to the corners. So, could you make a variable, call it capital A shift equals FFT shift of A? Oh, by the way, could you double the A, please, para madali na lang. Double of A. Yan. Yo. There we go. Yan. Okay. A shift. All right. Now, what we have is equation 4. Meron na tayong capital F dun sa equation 4. And ito namang A shift is capital G. Okay? And what you need to do next, Bea, is element per element multiply it and call it capital H. H equals F, big F, small f. Uy, girl. Ayan. Ayan, element per element. And then multiply by A shift. Pala, G, ginamit natin. But carry lang. Yan. So, na-convolve na natin siya in Fourier space. So, what we need to do is just invert this. Next line, so small h equals IFFT2. Yan, ang capital H. Yan. Do you understand what's going on? We have to go back to space, no? Para makita natin yung image niya. And now, pwede mo nang i-abs. Katulad kanina, yung i-display mo as an abs. Image SC, image SC, tas abs. Huwag mo nang i-shift. Tignan muna natin kung hindi na kailangan i-shift. Small h. Okay? Are we ready to run this? I don't know what will happen, but take a look. Teka, may error ata. Bakit ganyan na itsura niyan? Excuse me po, ano nangyari? Teka, may error ba?
No, it's just...
Wala? Tanggalin mo nga yung SC, ate. Alisin mo yung SC, image lang.
Oh.
Okay. Run that section again. Wala, lagot ako. Hindi ba ako, Bea? Ano nangyari? Teka, think. F, T, double, F. Hello, bakit ganun? Teka. Meron bang lumabas na image at all? Parang, may lumalabas ba? Are there dots?
Yeah, that's
Ay.
what.
Teka ha. Was there an error? There's no error message coming out?
No, there's not.
Teka. Think.
Here it uses FFT2 only without the I. Is that?
Sige, tingnan natin. 52 lang natin. What happens kaya? Sige.
No. Okay.
Yeah, it will just be upside down. Eh. Wait lang ah. Have we gotten it the same? Tama, may abs. Okay, wait lang ah. Hmm. Small h. Wait lang ah, I'm thinking hard. What is the wrong with you? Double F, tama naman. Okay. Wait, okay. Double A. All right. We had the glitch before. There's a reason why magkahiwalay yung ano. Could you try this please? Age image equals abs age, small h, you know. Age image equals abs age, and then let's see. And then you image age image. That doesn't make sense. Go ahead and image. Sige, sige. Type this, image age image. Hello. Bea, you still with us? Oh, Bea, hello.
What? Hello.
Age image. Sorry, image age image. Age image. Yo. Let's see what happens. For a while, I was surprised. Akala ko lumabas. Oh no, Bea, what's happening? Wait lang ha. Let me think. Naran natin yung A, di ba? Tama ba? Naran natin yun, di ba? Could you run it again, please? Naran natin yan eh. Ang section. And then, yeah, run this.
Is this right that we shift the aperture? Is it
That's right.
like that? Or
Dapat
because here
yun.
this one is going.
Ano daw?
Same.
Hindi,
Here.
tama yan. Dapat ma-shift yung aperture. Why? Because afterwards, ma-shift na rin uli siya. Kasi that's the reason why we don't need to shift the output. Abs na ano. Wait lang ha, hindi ko alam. Wait, ano nangyari? Could you show in this same section, could you show A, please? After, yeah, show image SC pala, image SC, because it's double na. A shift. We are supposed to see a quartered circle, right? No? Yon, tama naman. Okay. Now, can you show me the product capital H, absolute value of the product? Kasi this is complex, huh? This is a complex number. So we can take a look at the real part first. Could you show me image SC capital H? Yeah. Oh, now we have a problem. What did it say? Error using image. Complex values. Ay, abs pala, te. Kailan ko lang ng abs. Paki-abs lang. Ay, real. Sorry, te. Real. Yun. Para yung real part lang. Yan. Okay. Supposed to be. Okay, that's correct. Expect that. That's expected. And that's supposed to be. So you can also image the imaginary part if you replace real by imag. Yeah. Well, yeah, that's it. So essentially, okay naman tayo.
Mm.
So what needs to happen is, okay. So hindi ko alam kung bakit hindi na nag-work yung speech. Okay, FFT2. Could you take a look at capital H to see in the workspace, is it complex? Dapat complex siya, right?
Yeah.
Capital H. Okay. And small h is also complex?
Yeah.
Why is it 3 by 3? Oh! Integrate. Ayun ang problema natin. Hindi natin na-integrate. RGB to gray. Integrate. Integrate muna natin. Kaya pala. Hirap siya. Because this is an image. Naalala mo yun, te?
Mm.
Di ba? Di ba? Remember the circle? We have to integrate that. Di ba?
Oh, kanina. Yeah. Oh, yeah. So much there.
After im read, you can make patong to FF equals im to gray F. Pwede naman yun. Yan. Kaya pala. Sige. Hope to see it work now. There you go. That's looking like something. But, okay. Now it's working now. You can see the NIP, but it has ringings. Now to make it color map gray para magmukhang Okay. All right. Mas obvious ba yung kanina? Tama ba? What are we looking at? Age image. Wait. I think we're looking at age. Yeah. That's it. Hindi halata yung hindi halata yung ringings nung hindi siya grayscale, no?
Yeah.
Hindi halata yung ringings noon, pero nung grayscale medyo, no? You zoom in. Yeah, I see what you're doing. You're trying to zoom in on the edge. There it is. Oh, can you see that? There it is. Do you see that ringing? Di ba pag tumitingin kayo ng cells, minsan nakakita kayo ng may ganyan na artifact? Have you ever seen that kind of artifact? Looking under the microscope or a telescope. That's it. Now, repeat this, but this time reduce the size of the aperture. It will become more apparent if we make it smaller. Okay. We are letting in less light, and therefore we are not collecting enough rays to reconstruct the image. We're losing some information. Okay. Have a look at that, guys. Di ba? Nagmumukha ng parang di ba? Distorted.
Yeah.
Cool, di ba? So here you see, the larger the aperture, the more rays it can collect. Okay? The more rays it can collect from the image, the more light it can collect, the more it can reconstruct the image. That's why palakihan ng telescopes pagdating sa astronomy, guys. Di ba? The larger the dish, the more you can collect rays from out there. The smaller the dish, the smaller the lens, the less the rays you can collect. Okay? Cool ba? So if you increase the size, it will become nearly ideal. Konti na lang yung yung ringings. And you can see this from yung kanina nung ginagawa natin yung circle. Tapos Fourier transform natin siya. Nakita niyo, di ba, airy pattern yun? But remember what happens if you have a larger circle, you have a tinier airy pattern. Also, the rings are tinier. So you would have less of these artifacts, or rather fainter of these artifacts showing up. But when kanina, nung pinaliit ni Bea yung circle, tapos Fourier transform niya, mas nagiging prominent yung airy pattern rings, right? And so it shows up when you convolve that with an image and when an object, this comes up. Convolution, when you convolve two functions, they look a little something like both. Nalala niyo yung sinasabi ko sa 183? If you have a square and you convolve it with a circle, the resulting image would be a little something that looks like both because you smear one against the other. Same with this NIP image. You have an NIP image and you smear it with a airy pattern, so it looks a little something like both. Cool ba?
Yes.
Ayos ba? Bit. Too much? Pahinga? Kaya pa?
Yes, ma'am. Thank you. Oh, okay.
Okay. Kaya pa? We have just enough time for the last. For the next one. Correlation, no? Okay.
It's 9:45.
Sensya na, naririnig niyo yung timer ko kasi I need to be reminded of the time always. Okay. Okay, guys. The next application ng Fourier transform is in correlation. In correlation, have a look at equation 5. Halos pareho lang siya ng convolution. Maliban na lamang na naging plus yung minus sign kanina. No? Halos pareho lang sila actually kung symmetric yung image. Alam niyo ba yon? Kapag symmetric din naman yung image, doesn't matter if you use a plus or a minus here. Kung kunyari yung G, ang function niya is even. An even function means it's symmetric about 0, no? Same, it looks the same whether you look left or right from the 0. So it's an even function. So correlation equals convolution so long as G is an even function. Okay? Ano bang ginagawa nitong correlation? Correlation is pattern matching. So imaginein mo, may dalawa kang functions, f and g. No? Kung f is identical to g, ano mangyayari kapag in-apply mo yung equation 5? Magpapatong sila at the point where they coincide exactly. Kasi shifting yan, no? Look at the equation there of g. It's gonna be shifted by some x prime y, by x and y. Ang dimension ay ang units niya is x prime y prime, no? The integral is in x prime and y prime. But it's gonna be shifted by a value x and y, right? So what happens if this x and y shift happens to coincide exactly with the position of f? So you have two circles. One is F and one is G. The circle G, they have the same size. They have the same radius. But the circle G is moving around. Okay, you can shift it anywhere, any XY, no? So what happens if napunta si G on top of F, exactly on top of F? What happens to this equation 5? Well, parang nag-square yung F, no? Parang since F equals G and exactly at that point, nag-match yung positions nila, no? De parang F squared na to. Parang nag-integrate ka ng F squared. De magiging maximum yung value niya at that position, X and Y. So yun yung sinasabi na template matching. Kasi kung nag-match yung pattern, nagkatagpo sila at that spot, the correlation image would be very high at that position XY. All right? Have a look at equation 7 and 8. Essentially, what this is equation 7 and 8, dahil kahawig siya ng convolution, medyo sumusunod siya dun sa nangyari na Fourier transform din na product, pero ang kinaiba lang is equation 8, no? Dahil dun sa plus sign niya sa equation 5, magiging F conjugate times G. Hindi lang yung kanina sa convolution, F times G. Ito, i-conjugate mo muna yung F bago mo i-multiply sa G. Capital G, no? At iyon yung magiging correlation image. Get you, ah? Alright? So, Pag sinabi mong conjugate sa complex, kasi Fourier transform, ang lumalabas dyan, hindi real numbers, complex numbers, may real and imaginary part. So pag sinabi mong i-conjugate mo yung function, babalitan mo lang, i-flip mo lang yung sign nung niya, yung imaginary part. Pag positive, magiging negative, and so on. Yun lang. And sa MATLAB, it's just as simple as calling the function conj, C-O-N-G. So C-O-N-J. Okay, so you just conj of F, and that's already conjugate of F. Now, sige, move mo Bea doon sa template matching using correlation. Ang kwento dito, gagawa naman kayo ng pattern. This time, it's a sentence. The rain in Spain stays mainly in the plain. And then, we're gonna make a pattern using the same font, using the same size of fonts, A. In business circle, we will use A. That will be our target pattern. No? So, ang gagawin mo, Bea, is if you read the instructions, you will make this image that says the rain in Spain stays mainly in the plain. You make another image, and this time it's an A image, same font and size as the A's in that first image. And then you're going to template match or correlate them. How? You take the Fourier transform of one, then you take the conjugate of that, you take the Fourier transform of the other, and then element per element, multiply them together. And then, just like what we did in convolution, inverse Fourier transform, and then display, and see what happens. Can you do that? Okay, can you imagine the steps, Bea? Hello?
Sorry. So
Huh?
we get the Fourier transform and then the conjugate of the Fourier transform, right?
Yeah. And then you multiply it by the Fourier transform of
Of the A.
the A. Get you what? So we will go
Mm.
back to Paint. We can do this in Paint. Sure, no problem. Just make sure that the font size is the same, huh?
Oh, okay. What's the 70?
So you can make another one and new function, new image. Adi, may tanong?
So far po, lang po. Yung dun sa first part, ang 2D Bell, yung Gaussian po na kailangan kunan ng discrete FFT ay yung same na image na ginawa namin na may circular aperture sa activity 2 or without the circular aperture po, yung Gaussian lang.
Yung wala. Yung walang
Okay.
circular aperture. Bakit? Because analytically, the Gaussian, ang Fourier transform niya is also a Gaussian. Yun yung kakaiba sa kanya. Wala siyang rings katulad ng circle. Kaya marami siyang uses kapag dating sa pag-improve ng image na nakuha using a circular aperture. PNG is fine, di ba? It works as well. Okay.
And then the A has to be the same.
Oo. And make it as centered as possible. Yung medyo gitnang-gitna. Okay? Small a, small a.
Oh, so
Make it as centered as you can. It matters, you know why? There's a thing about the shift of this A that will affect the output.
I think that's okay. more.
Hindi na siya nagagalaw. Never mind, it's fine. Sige. It will just introduce a slight shift, but you're ready. Okay. Now don't forget to integrate these guys, okay? Because they're saved as an n by 3 as per our experience, right, Bea?
Okay.
Tingnan nyo guys, kung attend kayo ng ganito, parang natapos nyo na yung experiment. Sabihan nga yan si Carl. Sinusundan nyo lang to eh. Tapos na tayo dito sa ano, report na lang, right? Diba, Adi? Girl, pwede mong idiretso yan. Im to gray, im read, rain. In one line, pwedeng yan. No. After im read. Im to gray. Yeah. Sorry, not after im read. Before im read. Kasi parang nested ba?
Yeah.
Isn't that nice? Okay. Or you can call this, what do you want to call this? F or G? Bahala ka. So,
And then
you can call this a G. Sige. Bahala ka. You know what to do. You already know what to do, huh?
wait, this is already okay. Same.
Yun. Galing talaga ni Matlab. Oh, sinasuggest niya na, oy, TPNG. See? Yun. Okay. Ay, small f. Mali. Girl, pwede bang gawin mong small f, small g? Kasi capital F, capital G, normally Fourier transform na yan eh. Yan. Okay. Capital F equals, ang gawin mo ay, ano ba ito? FFT2 double small f, di ba?
Yeah.
Right. And do the same for our friend there, the G. Yes. And then capital, ano yung gamit na H? Ano yung gamit natin? P, capital P. P equals conj F element per element multiplied by G. There you go. Woohoo! And now the usual small p equals inverse Fourier transform 2 of capital P. And then image, I think we can go ahead and image abs. I think, well,
Or
sige,
image there. That's it.
and then color map, gray or whatever. Okay. Okay, exciting. Are you ready?
Okay.
Hey. What again is the problem? Like, wait, let's see. Is it times 3? Di naman.
No.
Capital F is complex, yeah. It's not
Yeah.
3 by 3. Capital G as well. Small p. P complex, but then we abs it. Well, could you show me the image again? Maybe we need to image SC this. Could I ask you to put an image SC there? Yeah. And run the section again. There you are. Okay, it's just, too elevated, I think. So we had to stretch the contrast. Okay, what I see here is medyo ano siya. Girl, pwede mo bang instead of inverse FFT2 use FFT2 lang, baka matanggal yung yan. Sige, just run it again, see if it works. Okay, there's a shift. Do we need to FFT shift this? Wait, teka lang ha, let me think. But because, no, it's not supposed to be FFT shifted. It's okay. Kasi in inverse to. Let's see, could you put FFT shift just before abs P? Yeah, FFT shift. There. Because it's showing up, it's just that it's shifted. There. Okay. Do you see the points where there seem to be a
It's
bright
10
dot?
o'clock.
Yes.
You can also display this as a mesh. But essentially, kung saan mataas, ibig sabihin mataas yung correlation ng pattern A with the image. So the rain in Spain stays mainly in the plain. Can you see that? Can you imagine? There's these bright. By the way, instead of color map gray, let's see color map another color para mas medyo enhanced. Choose one among the many there. Cool, yeah. Ouch. Wala bang iba? Wait, parang ang sakit sa mata. Iba na lang, te. How about, tingin pa tayo ng iba.
Awesome.
Ito. Ano, jet. Kasi, jet. Sige, okay yan, jet. Kasi rainbow colors yan. What the hell? Pero anyway, can you see the red? Nakikita mo yung red, ano? Yung nagpipick siya sa mga red parts.
Yeah.
Diba? It matches the rain in Spain. So there's an A there. Stays mainly in the plain. Kapag meron ding medyo pang malapit na peak, ibig sabihin halos pareho yung yung pattern. Kaya nga template matching to eh. Kung medyo malapit magkamuka, pati yon, sasabihin niya medyo kamuka, mataas ang pagkakamuka nito. That's why it's template matching. But now, suppose you're looking for a word, okay? Or a phrase. So, kunyari, rain. Pinahanap mo yung word na rain. Can you do that? Or in. Kasi di ba maraming in dito eh. The rain in Spain stays mainly in the plain. So, maraming word na in, right? Let's make an in. You can do this at home kasi patapos na yung time ko. I have to leave now. But instead of A, Bea, try to make the word in, no? And see what happens dito. But you can see this is how correlation works. It will peak where it sees a maximum match of the pattern of the target in the test pattern. Ayos ba?
Yeah. Okay.
Okay, cool. That's template matching. So you can have two letters, a phrase, a word, and it can look for that match. So long as they exactly look like each other. Okay? Cool?
Yes.
That's it. Ayos ba?
Yes, ma'am. Thank you.
Yeah. Naging 186 session. Di bale? Okay lang yan. Whatever you need. Sige, fine. I'm good with that. Okay na, Adi? Did you see that, Adi?
Yes.
I hope it helps. The next activity is fine because we will actually use real world samples using these lessons. Okay? The next activity, Bea, activity 5, it gives you real world samples where you use for your transport. Okay?
Okay.
Okay? That's it. We're done for the day.
Okay. Thank you.
Bye,
ma'am.
guys.
Thank you,
Bye.
Doc Jean. Bye po.
Bye.